Okay, so we're going to talk about the reciprocal trig functions today, and those reciprocal trig functions are right here. Cosecant, which is abbreviated CSC. We've got secant, which is abbreviated SEC, and we have cotangent, which is abbreviated COT. All right, and we're going to talk about these three today. And the reason that they are called reciprocal trig functions is they are each a reciprocal of one of our original three trig functions. So cosecant is the reciprocal of the sine function. It's 1 over the sine value at that angle theta. The secant function is the reciprocal of the cosine function, so 1 over cosine of theta. And cotangent is the reciprocal of the tangent function, so it is 1 over the tangent function. All right? So far, so good? Okay, so when we're looking at the unit circle, which we're going to use to find some of these reciprocal trig function values, do you recall how x is your cosine and y is your sine? So cosecant, which is really 1 over sine, is going to be 1 over whatever your y value is. The secant, which is 1 over cosine, is going to be 1 over x, because x is cosine. And the cotangent, which is tangent upside down, because remember, tangent is the y value over the x value. Well, cotangent is x value over the y value. Now, the trick to this is keeping track. We know tangent and cotangent go together. They're reciprocals of each other. But keeping track of which goes with which, cosecant and secant with sine and cosine. Keep track of it this way. Cosecant and cosine do not go together. So cosecant must go with sine and secant must go with cosine. The two cos don't go together. All right? So if we want to go down here to example number 1, and we want to find the exact value of negative 5 pi over 6. So we're going to go 5 pi over 6 is right here on our unit circle, right? So we went around to here. Negative 5 pi over 6, to get that, you can either add 2 pi to it or go this distance in the clockwise direction, which would be right here. All right, now we want cotangent, which is going to be the y value over the x value. Well, now we want, the cotangent is the x value divided by the y value. So, here's what we're going to do. Put this off to the side. The cotangent of negative 5 pi over 6 is going to equal the x value over the y value, which in this case is going to be negative square root of 3 over 2 divided by negative 1/2. To get this exact number, keep switch flip, so negative square root of 3 over 2 times negative 2 over 1 gives us positive square root of 3. Okay? All right, how about cosecant pi over 6? So let's go to our unit circle, and here's pi over 6. Which one does cosecant go with, the sine or the cosine? The sine. And the sine is which, x or y? Y. So this is going to be 1 over y. So 1 over 1/2. And we're going to do keep switch flip, which gives us just 2 as our cosecant value. All right. Now, if we wanted to find these on our calculator, If you take a look at here, you see you have a sine, a cosine, and a tangent button, right? So it's fairly painless. Let's get this camera worked up here. To find the tangent of 10, you're just going to put in tangent 10. Make sure you're in radians unit when you do this. And there you go. You're going to get your decimal. So round to the nearest thousandths, how many decimal places is that? 3. So 0.648. Now, we don't have a key for secant. Secant goes with which one? Sine or cosine? Cosine. Cosine. So here's how you find that. You're going to do 1 divided by, and then you're going to do cosine of 2. That is how you get the secant value. And here we have negative 2.403. All right, so that's also how you get these on your calculator. Okay? Do you understand that if you want to find exact values, when you're finding exact values, we can only find those for some angles, principally the angles that we find on our unit circle. For those angles, you can find exact values. When you're using your calculator to find trigonometric values, these decimals are what we call approximations. They are not exact. They are approximations. Okay, so let's go ahead and turn the page, and we're going to graph. So it says graph the following from the interval from 0 to 2 pi. And we have y equals sine x with y equals cosecant x. This is actually really cool. It's just a cool exercise to do. I'm going to call this 1 right here and this negative 1 right here. And the first thing I'm going to do is let's color in y equals sine x. And we know that it starts here, hits 1 right here, back to 0, down to negative 1, and over here to 2 pi, and we know it looks like this, right? So that's y equals sine x. Now we want to do y equals cosecant x. Now, all we have to do is we have to take each of these values and do 1 divided by that value, right? And then we're going to need to fill in some more. So this is 0. What's 1 divided by 0? Undefined. So guess what? Asymptote. Okay, go here. 1 divided by 1? 1. 1 divided by 0? Undefined. Asymptote. One divided by negative 1. Okay. And 1 divided by 0? Asymptote. Okay. So the question is, what is this doing in between the asymptotes? So let's do this. Would you agree this point right here is pi over 4, right? Okay, so let's go to pi over 4 on our unit circle. So here's pi over 4. And our sine value is the y value, which is the square root of 2 over 2, right? Our cosecant value is the reciprocal of that. So 1 divided by the square root of 2 over 2, which is 2 divided by the square root of 2, right? 2 divided by the square root of 2. All right, we need that as a decimal so we can graph it. So 2 divided by the square root of 2, 1.41. So maybe right about there. Let us do the same thing. This right here is 3 pi over 4, which our y value is the square root of 2 over 2. Same thing. So it'd be 2 over the square root of 2, which is going to be 1.4 right there.
Why are you putting them so high up?
What do you mean so high up?
2 over 1.4.
This is 1.
Okay.
All right, so if we go down here, this right here between pi and 3 pi over 2 is 5 pi over 4. And now we have that same number, but it's negative, so negative 1.4, right? Okay. Which is right here. And if we go here between 3 pi over 2 and 2 pi, 7 pi over 4, and we have that same value, negative 1.4. So that is here. And this is what it's going to look like.
Wait, I think Trig felt like doing this right now. Right now?
Great, add that to my video. Okay, so this is the pattern. It keeps repeating to the left and to the right. And the interesting thing is, in every interval between the asymptotes, it switches direction. All right? And it's always going to touch the top of the sine curve. Now, we're not going to do secant in class, but let me tell you what. Secant does the same thing to the cosine curve that this does to the sine curve. So it'll look similar. So let me just show you, for example. Come on, come on. All right. Incidentally, for your videos, this would be a good thing to pay attention to because I'm going to show you some tricks about graphing trig functions on Desmos. First of all, I'm going to draw y equals cosine x, okay? So y equals, go over here to functions, bring that up, cosine, and then I'm going to put an x in there. Now you'll notice it doesn't have pi and 2 pi and all that business on it, and we would kind of like it to have that, would we not? Okay, we can fix that. Go to the little wrench up here in the corner. Okay, so on my y-axis, I want this to be a little bit bigger, so I'm going to take this, instead of being negative 10 to 10, maybe I'll make it negative 5 over here to 5, okay? So I just made it a little bit smaller, and my step, I'll make that 1. All right, so my x-axis, I want this to go from, how about negative 2 pi to positive 2 pi. So here's what you're going to do. Negative 2, and then down here is the pi key. All right? And I want it to go to positive 2 pi. If you only want from 0 to 2 pi, put that in. And like, here's what I'm going to put as my step. And you can use whatever you want as your step. But what I'm going to do is use pi divided by 2. So pi over 2 is my step.
Wait, what does that mean again?
That means at what increments do you want a line to occur?
Oh,
Okay? So now when you look at my graph and like you see, here's my graph, right? And it shows increments of pi, which is very, very nice. So now let's put in here secant. So y equals, let's pull this up and see if they've got secant, and they do, secant x. Do you see how that looks? And it does the same thing that cosecant does with the sine curve, secant does with the cosine curve. Very, very cool. Okay? And if you want to graph your asymptotes, you can actually graph them in here as well. Do you know how to graph your asymptotes? Oh, it's so cool. Just draw. So, would you agree? I have an asymptote right here at pi over 2, right? So all I'm going to do is I'm going to put x equals, and then I'm going to put pi divided by 2. And look, it puts a line there. And I believe that if I touch on this, wait, hang on. There we go. I can make it like a dashed line, a dotted line, or a dashed line so that it looks like an asymptote, like how we draw them on our paper in class. Pretty cool. Touch right here on top of your little squiggle. Yeah, over here, and it brings up this box.
It makes my line disappear.
I can help you later, but do you think I should get away and walk away from my video at the moment? Yeah, probably not. Okay, so that's how you do this on Desmos. So anyways, let's go back to our graph. And here is tangent with cotangent. Now this one does something a little bit different. So let's first of all draw in our tangent curve. And we'll do this one in the green. And as I hope you recall, we have asymptotes at negative pi over 2. Then we have one at pi over 2. And then we have one at 3 pi over 2. And so here's our graph. Remember, it's going to cross right here, and it's going to go up like this. And it's going to go down like this, right? And here, and it's going to go up like this, and down like that. And over from here, we're going to see it go down like that. So there's tangent, right? So let's put some points in, and something you need to realize, you know that when we graph the tangent function, if you go here to pi over 4, x and y are the same, right? So y over x is going to be 1, right? And if you go over here to the next one, this one's going to be negative 1. Then this one's going to be 1, because it's negative divided by negative. And then over here, negative 1. So keep in mind that this is a point, this is a point, this is a point, this is a point, and this is a point. So this is the reciprocal of this, so it's 1 divided by that. So what is 1 divided by 0? Asymptote. And this is an asymptote, so we'll have to come back to that. Go to the 0 again. This is going to be an asymptote, right? All right. And this is going to be an asymptote again. Okay, so now, what is 1 divided by 1? Okay, and what's going to be 1 divided by negative 1? Okay, so I want to go to this point pi over 2. And the reason we're going to go to pi over 2, because we don't have a point there that we can say, oh, what's the reciprocal of that? So we're going to go to pi over 2. And remember, cotangent is not y over x, but x over y. So 0 over 1, which is? 0. So that's this. And what we essentially have here is this. And it repeats over here, goes right through this one, like this. Do you see? Pretty cool pattern, eh? That's how tangent and cotangent are related. Pretty cool.